Finite theory of the universe, dark matter disproof, and faster than light speed. I will present you my theory by first showing the differences between special relativity and finite theory. I will then show what finite theory is and how it is able to make predictions that general relativity cannot do. First, as we all know, ether was first proposed by Fresnel in the 19th century. It was viewed as a uniformly distributed substance that is static and by which planets are traveling through. It was later shown by the Michelson-Morley experiment that ether could not be detected. Albert Einstein went on saying that there was absolutely nothing present and based special relativity on this assumption. Now we have both extremes. What could be any different from these two possibilities? Finite theory concedes ether to be actually the sum of the gravitational potentials of all masses. It also has the same spin of the emitting body. In other words, gravity is considered to be a particle and therefore unifies well with quantum mechanics. The spin explains why the Michelson-Morley experiment hardly detected ether on the surface of the Earth. Second, special relativity considers the frames to be relative. This means if we have a spaceship traveling at speed c minus epsilon and emits a beam of light going in the same direction, it will be observed to travel at speed c. Furthermore, if it emits a beam of light traveling in the opposite direction, it will be observed to travel at speed c as well. The difference with finite theory lies in that the reference frame is actually absolute. In other words, the speed of the light beam traveling in the same direction of the spaceship will also be seen to be c, but if it is sent in the opposite direction, the observed speed will be infinite. If we want to go further, we will have to conclude that both postulates of special relativity are actually wrong. Furthermore, from the sole exception of time dilation, all of the following concepts are actually considered to be wrong, starting with length contraction, which was never directly proven experimentally. Mass increase, which can be explained by an increase in momentum in particle accelerators. The equivalence principle, which is a generalization of the postulates of special relativity about the constancy of the speed of light. Singularity wormhole, which is general relativity pushed to its mathematical limits because time is considered to be a dimension, thus can take positive and negative values. The Einstein's constant, or kappa, which is basically a representation of the ambient gravitational potential of the solar system, but which is not scalable. The cosmological redshift, which shows the laws of conservation of energy, is not respected by general relativity. Dark matter and dark energy, which are simple plugins and were never directly proven experimentally. Let's examine the wormhole. Time being a dimension in general relativity, it needs to be extended below zero and reconnect to an unspecified location in space or where its associated white hole should be. This doesn't make any sense. Another area to examine is Einstein's constant, or kappa. Like I was saying before, kappa represents the ambient gravitational potential for the solar system, but it is not scalable, and thus kappa cannot be used for different solar systems, galaxies, or clusters. This is exactly the reason dark matter was invented, because the maths of general relativity are not extendable. Finite theory offers an alternate solution where the time dilation is the product of the kinetic energy relative to its maxima, and the superposed gravitational potentials. The latter is what we show here. The theory is deductive. To illustrate these two postulates, let's visualize an atom submerged in a gravitational field. The first postulate simply states that by increasing the kinetic energy or speed, the graviton flux will be proportionally increased, thus it will slow down the kinematics of the atom. The second postulate similarly states that by increasing the gravitational potential, the graviton flux will be also proportionally increased, thus slowing down the kinematics of the atom. How is finite theory represented? The time dilation outside a sphere is in big part how it is represented. Indeed, since the inertial body being subject to a specific gravitational force is responsible for the gravitational time dilation, and that gravity is a superposable force, we will translate the same condition for all gravitational potential into the sum for all surrounding fields of an observed clock and the observer. Finite theory wouldn't go anywhere without first going through what was predicted by general relativity as far as the Perihelion Precession disparity, the gravitational light bending, the expansion of the universe, and the galactic rotation curve are concerned. So I wrote a simulator to get some estimates. I was surprised to see constant results which were similar to what is observed as far as the Perihelion Precession disparity is concerned. This is a great discovery. I get the following results. Mercury is 5 times 10 to the minus 7 radian per cycle. Venus 1.8 times 10 to the minus 7 radian per cycle. The Earth 1.3 times 10 to the minus 7 radian per cycle. One of the most practical and interesting goals of any research area in this field is the reach for exoplanets. Unfortunately, since general relativity disallows any probe or ship to travel faster than 300 times 10 to the 6 meters per second, we reach an impasse because one of the closest stars, Alpha Centauri, is about 4.36 light years away from us. This means a light ray will take 4.36 light years to overtake that distance according to general relativity. Finite theory is distinct in that it predicts natural faster than light speed. This means the time it will take for a photon to travel between two planets, two stars, or two galaxies is given by the following equations, where h represents the gravitational potential of the universe at a given scale. But the question is, since the speed of light is not constant in nature, why not manipulate it? Effectively, by creating a tunnel with a lower gravitational potential, we will observe beams of light traveling faster than light for an observer outside of the tunnel. This means if we have two spaceships where in this example the top spaceship is in a normal gravitational potential and the bottom spaceship is in a tunnel with a lower gravitational potential, then we will see the bottom spaceship outracing the top one because everything in that tunnel is speeded up. But finite theory stands apart because it is able to predict the galactic rotation curve where general relativity can do without the use of dark matter. The idea of dark matter is to replace the missing matter necessary to withhold all the tangential galaxies within their cluster traveling at a much higher velocity than their necessary escape velocity. Dark matter explains also the same scenario at lower scales where tangential stars should technically easily escape the attraction towards the center of their galaxies. Unfortunately, after many attempts to unfold the nature of dark matter, no conclusive discovery can be revealed. So we see here the necessary velocity our Sun needs having in order to maintain its orbit around the center of the Milky Way, according to Newton. In contrast, by using finite theory as a mathematical representation, we will find a much different conclusions. Indeed, the stars and galaxies rotating around their galaxies and clusters respectively will be subject to time contraction. This means the body will be seen to travel much faster than their anticipated Newtonian speed. There is therefore no need for any dark matter to increase the gravity strength necessary to keep the tangential object in an uninterrupted cycle. The galactic rotation curve is given by the following equation, where h is the scaling factor of the cluster the galaxies reside in our example. For normal galaxies, we will have the following curve. This is the same pattern as to what is being observed. What about low surface brightness galaxies that are observed to have a different curve? Finite theory can account for those galaxies by simply lowering the scaling factor of the cluster. This will give us the following curve, which once again matches the observations. The composition of a black hole, a question still unanswered, is solved here. But first, I would like to point out that the Schwarzschild radius is solved differently according to finite theory. We can find more about its explanation in my paper, where I show that it can be found by equating the maximum kinetic energy of a photon can have with its maximum gravitational potential. The mass of a photon is of non-importance because it is simplified. Thus, we have the same equation using different methods. So if we take the smallest black hole that can be created, or the black hole created by the proton, we will have the following radius. Once again, since nothing can cross the even horizon, according to finite theory, the layers of mass can only be accumulated over this even horizon. This means that 2.5 times 10 to the minus 54 meter is the maximum compression matter can reach. If we compare that to the radius of a proton of 8 times 10 to the minus 16 meters, which is another maximum compression matter can reach, we will see that matter will never be able to reach the compression of a black hole. Therefore, a black hole is by definition can never exist. Only a close-by counterpart made up of very unstable subatomic particles can exist according to finite theory. Here I disprove dark energy. First, as we know, the Hubble's law is given by the following equation. This is a straight line with a specific slope. If we use finite theory in case where the universe is not encompassed by any greater entity, then the observed speed of the galaxies minus the speed of we are actually traveling is given by the following equation. This equation is the same as the Hubble's law. By equating both equations, we can easily find the center of the universe giving the speed of the observer or the Milky Way. This means if the universe has no velocity, then the speed of the Milky Way is 600 kilometers per second, which means the position of the center of the universe is minus 2.66 10 times 10 to the 23 meters. This is right outside the Virgo cluster, which is we are located in. Thus, this doesn't make any sense. This would imply the universe itself must have a velocity of its own if we want the kernel to be farther away. The two equations will give us the following plot. The most interesting part of this is by superposing the Hubble's law with finite theory's solution and knowing the speed of the Milky Way, we can solve the distance we are away from the center of the universe. Visually speaking, the universe will look like the following, having outer galaxies traveling away faster than inner ones. Our perception will be as if the galaxies are traveling away at an accelerated rate relative to us. You can see clearly why there's no need for dark energy. The question is if the kernel of the universe we see on the left is really part of the visible universe. It most likely is not because of the following reasons. Within the visible universe, we cannot see an entity bigger than a galaxy. According to my last estimate, the visible universe must have a velocity relative to a greater universe, otherwise the center of the universe is next to our cluster. Given that the scaling factor h of the Milky Way is around 7 times 10 to the 26 kilogram per meter, and that for the Virgo cluster it is around 5 times 10 to the 23 kilogram per meter, it is still so high that it most likely it won't be null at the scale of the Virgo supercluster. This means the universe is encompassed by a greater entity. Here I've shown you 3 reasons to believe the visible universe is part of a greater one. Lastly, my theory is testable as I do have an experiment ready to be performed and consists of sending a wave meter of high precision at Mach 3 aboard a suborbital spacecraft. This concludes my theory. It was shown that finite theory can not only replace general relativity, but really stands apart by predicting the constitution of a black hole, the GPS time dilation, the gravitational light bending, the Perihelion Precession disparity for all planets, the galactic rotation curve for all galaxies, the expansion of the universe, but most importantly, given that gravity is considered to be a particle, controlling it is encouraged in order to build a faster than light tunneling effect completely artificially. You will find the paper in the simulator I was referring to at the following website, finitetheory.com. I also have a book called Imagine If Einstein Was Wrong that you can find on Amazon or Author House. And for any question, you can reach me by email at pbouchard8@gmail.com, and I will be happy answering your questions. Thank you.